The question is, derive an expression for the electric potential due to a point charge. So first we shall know about electric potential. Imagine that a charge capital Q placed at origin, which is positive. This charge capital Q produces electric field nearby. Now, at infinity, we have a positive charge Q0. Q0 can be also taken as a unit positive charge. So now we have to bring this charge Q0 from infinity to some point inside the electric field of charge capital Q. So for that work has to be done. So now work done in bringing charge Q0 from infinity to point P can be taken as W, and electric potential is given by V is equal to W by Q0, where Q0 is the unit positive charge brought from infinity to point P. Now we shall derive the formula for the electric potential due to a point charge. Imagine at origin we are placing a charge capital Q. We wish to find electric potential at point P due to charge capital Q, which is at a distance r from the charge Q. To find electric potential at point P, we shall take a unit positive charge Q0 from infinity to point P. So this charge Q0 has been brought from infinity to point P. For that work has to be done. So this charge Q0 has been brought from infinity to point P. Now, in the path, for example, at some random point P dash, the charge displaced by a distance dx, so that it is at a distance, for example, x from charge Q. So when the charge Q0 is at a distance x from the charge Q, the force acting between charge Q and Q0 is given by force between charge capital Q and Q0 is given by F is equal to 1 by 4 pi epsilon naught capital Q into Q0 by x square. And work done in displacing the charge Q0 by distance dx is given by dw is equal to minus f dx. Negative sign indicates that the force and displacement are in the opposite directions. So now we can write dw as dw is equal to minus 1 by 4 pi epsilon naught capital Q into Q0 by x square dx. So now work done in bringing charge Q0 from infinity to point P is given by W is equal to integral of dw, which is equal to W is equal to integral of minus 1 by 4 pi epsilon naught capital Q into Q0 by x square dx. And the limits of integration are from x1 is equal to infinity and x2 is equal to r. We get now W is equal to, since minus 1 by 4 pi epsilon naught capital Q and Q0 are constants, we can take out of the integration into integral of, we can write 1 by x square as x power minus 2 dx. Limits are from infinity to r. So we know that integral of x power minus 2 dx is equal to minus 1 by x. Now therefore, W is equal to minus 1 by 4 pi epsilon naught capital Q into small q naught into minus 1 by x, and the limits are from again from infinity to r. So we can see that this minus will be cancelled out, and we will get W is equal to 1 by 4 pi epsilon naught capital Q into q naught. Now apply the limits, you will get 1 by r minus 1 by infinity. As we know that 1 by infinity is equal to 0, therefore we will get W is equal to 1 by 4 pi epsilon naught capital Q into small q naught into 1 by r. Or I can write W is equal to 1 by 4 pi epsilon naught capital Q into small q naught by r. So this is the formula for the work done in bringing a charge q naught from infinity to point P. Now electric potential is given by definition, it is given by V is equal to W by q naught. Now therefore V is equal to 1 by 4 pi epsilon naught q naught by r, again by q naught. So we can see that the q naught is cancelled here. So then we will get, this implies V is equal to 1 by 4 pi epsilon naught q by r. This is the derivation for the potential at a point due to point charge.